So the notes we're doing today are section 6.1, segment lengths and midpoints. Got a couple definitions to go over first. So a line segment is a piece or part of a line that has two endpoints. When you name a line segment, you can put either letter first. Notice how the notation above the line segment doesn't have arrows on either end. A midpoint is a point that divides a segment into two congruent halves. Look at the picture on this one. It says from A to M is the same thing as from M to B. The two little markings here and here show me that those two pieces are equal to each other. That means that M is a midpoint, and that means that from A to M, this first piece would be congruent to or equal to from M to B. So this symbol right here is a symbol for congruent. The segmentation postulate says that if you know how big part of a line is, like the first part, and then if you know how big the next part of the line is, the second part, they would add up to equal the whole thing. So it says part plus part equals whole, or piece plus piece equals whole. In this case, the length of segment AC would equal 14 because 10 plus 4 equals 14. In examples 1 and 2, we're trying to find the midpoint by counting. So you'll see in 1A, if I count in from the two sides, 1 right here is the point that's in the middle, and so that's what's given us the midpoint on the number line. We can do the same thing over here. So if I count in 1, 2, 3, 4, and then 1, 2, 3, 4, and then I've got one more to go on each side to get to that point that's right there, that's in the middle. On this one, the midpoint is equal to -1 because -1 right here would be the point that's in the middle. So if you have a number line, you can count to find the midpoint. In example number 2, we're trying to find the midpoint without counting in from the two sides. And so there's a couple different ways that you could do this. You could try to draw a really long number line, but that wouldn't be the most efficient way. To figure out what the middle of 10 and 150 is, you can count in from both sides. So 10 plus 70 would give you 80, and then 150 take away 70 would give you 80. But the other way you can find the midpoint is by adding up the two numbers and then cutting them in half. That gives you the middle of them. It's kind of like you're averaging them. So when I do B, if I add up 34 plus 72, let's see, that gives me 106, and then if I do 106 and if I divide that by 2, I would get 53. And so for this one, the midpoint would be 53. So to find the midpoint, you could count in, but if you're not given a number line, you can add the two numbers and divide by 2. And that'll also give you the middle of those 2 points. On example number 3, we're asked to find the midpoint of the segment using a coordinate plane. So on the first one, it's already done for you. You plot A, you plot B, you draw the segment that connects them, and then you're trying to find the point that's in the middle. So there's 2 ways that you can do it. You can count on the picture. So you can say to get from A all the way down to B, you would have to go down 4, and then down another 4. So halfway in between would be down 2 and down 2, and then down 2 and down 2. That's what gives you the midpoint right here. Notice though that you can also count on the points. So to get from 6 to 2, you'd have to go down 4. So you'd go down 2 to get to halfway there, and then you'd go down the rest. To get from 5 down to 1, you also have to go down by 4. So you'd go down by 2, and then you'd go down by 2 again. So on B, A and B are already plotted for you. And so let's use both methods on this one. To get from A to B, I'm going to have to go over 1, 2, 3, 4, 5, 6 on my x's, and then I'm going to have to go down 1, 2, 3, 4, 5, 6, 7, 8. So 6 and 8 would mean that I'd go over 3, 1, 2, 3, because that's half of 6, and then 8 would be 4. So I'd go down 1, 2, 3, 4. And so this point right here is going to be my midpoint. Let's check and make sure the pattern works again. So I go over 3, and then I go down 4. So the pattern is you're going up 3, and then over here you're going down 4. -5 plus 3 gives me -2, and then that works again. And then 6 take away 4 is +2, and then that works again. So that's how you can find the midpoint using the picture of the graph and counting on the coordinate plane. The point that's in the middle is -2, +2, and the pattern is reinforced by the picture of the graph. So to find the midpoint of any segment without drawing a graph, you could find the middle of the x's and you could find the middle of the y's the same way that we did up above in example number 2. When you're solving to find the midpoint and you're just given 2 points and no graph to use, this midpoint formula shows you how you can find the answer to your question without using a graph. So it says you're going to take the 2 x's and add them up and divide by 2. So on this one I'll do -4, that's my first x, plus -8, that's my second x, and I'll divide those by 2. And then I'll take my first y, which is 3, and I'll take my second y, which is -9, and I'll divide those by 2. So you're plugging the points into the formula, and then from there you'll just simplify. -4 plus -8 is -12. +3 plus -9 is -6. And then -12 divided by 2 is -6, and -6 divided by 2 is -3. So without using a graph, you can solve to find the answer of the midpoint, or the point that's in the middle of these 2 points that are given to you, just using the midpoint formula. In example number 5, that point that's circled in red right here, M, is a midpoint. And you know that it's the midpoint because the little markings on the picture tell you that this part and this part are the same length. It doesn't tell you what the whole segment is equal to. So you can't say this one plus this one equals something, but you can say that the piece on the left, x plus 2, is equal to the piece on the right, 2x minus 3. And so going through and solving that equation for x will give you x equals 5. This question wants you to find the length of segment MZ, so once you get that x is 5, you take that answer and you plug it in for x right here. So to find out how long it is from M to Z, you would do 2 times 5 is 10, and 10 take away 3 gives you 7. So we'll apply that to this example over here. On this one, I'm being asked to figure out how long is it from P to R. So when I find my answer, they want me to find the whole thing. This only wanted me to find half of the answer, but on this one it wants me to find the whole piece, and so that's a little bit different. Let's see, so M is the midpoint because these 2 little markings on the picture, just like they did over here, tell you that the 2 pieces are equal to each other. So I'll say 5x minus 7 has to be equal to 3x plus 1, and then I'll go through and I'll solve for x from there. So 2x minus 7 equals 1, so that'll give me 2x equals 8, which gives me x equals 4. Now to find the answer to the question, they want me to figure out the length of the whole thing. So I can plug the 4 in to find out how long is it from P to M. So let's see, that would give me 5 times 4 minus 7, 20 minus 7. So that's going to give me 13 for this part. And then if I do 3 times 4 plus 1, that'll give me 12 plus 1. If you plug the 4 into both of these and don't get the same answer for both parts, it means you either made a mistake when you plugged it in or you made a mistake when you were solving. So x equals 4 gives me 13 for this part and 13 for this part. Now, to find the length from P to R, I need to do 13 plus 13 because it didn't just want me to find out this one and it didn't want me just to find out this one. It wanted me to find out the length for the whole thing. So the length from P to R is going to be 26. And that'll be my answer to the question. If it only wanted me to find the length of part of it, I wouldn't have to plug it into both parts. I would only have to plug it into one. So in the final example today, point V kind of looks like it's in the middle, but there's no markings on the picture that tell you that these 2 parts are equal to each other. So I can't set 2x equal to x to solve on this one, but I can use a segment addition postulate, which says that this piece plus this piece is equal to the whole thing. So 2x plus x is equal to the total, which is 15. I solve for x, and then on this one they want me to solve to find the length from T to V, so I would plug it in to this one. 2 times 5 would give me 10. The segment addition postulate does not say that the 2 pieces are equal, it says that the 2 pieces add up to equal the whole thing. So on this one, again, there's no markings that say that J is the midpoint. So for this one I'm going to say 5x, the left, plus 3x minus 8, which is the right, is equal to 32, which is the length of the whole thing. And then I'll solve for x from there. Let's see, I'll add the 8 to both sides. So 8x equals 40. And so on this one, when I divide both sides by 8, I'll get x equals 5. And then, let's see, for this problem, they want me to solve and find the length from j to k. So to find the length from j to k, I'm going to take the answer that I just got, which is x equals 5, and I'm going to plug in the 5 for the x right here. So it'll be 3 times 5 minus 8, which will give me 15 minus 8, which will give me 7. So the length from j to k would be equal to 7. And if jk were equal to 7, then the total would be 32 based on the numbers that are given. So oftentimes with the segment addition postulate, you'll be setting up an equation solving for x, and then you'll be plugging that number x back into one of the equations to find the answer that you're looking for. You just want to make sure you plug it into the right piece.